Homework 13, measures of average video 4, mode. Now, most of you are probably familiar with mode. It's the number or value that occurs the most. But there are some things I need to clarify about mode. Let's start with its definition. Excuse me. Consider any data set, x1, x2, all the way through xn. And what I mean by any data set is qualitative or quantitative. So either non-numerical data or numerical data. This is the only measure of average that applies to non-numerical data. The mode is the value or values, so there could be more than one, with the greatest frequency. So if we were to make a frequency distribution, it would be the value whose number in the frequency column is the greatest. However, if all values have a frequency of 1, there is no mode. In other words, if everything occurs only once, there is no mode. So let's take a look at these 4 examples, 2 of which are qualitative, 2 of which are quantitative. The first of which is qualitative. The quality here is the type of animal that you are. Dog, fish, cat, and dog. Which value has the greatest frequency? I think it's pretty obvious. It's dog. The frequency is 3. Nothing else occurs more than 3 times. Dog occurs the most in that data set. Now, if I threw on another cat, then both dog and cat would be the mode because there would be 3 cats. What about the next data set, which is quantitative? 1, 2, 2, 2, 3, 3, 3, 4, 4, 5. Which value occurs the most? 2. The frequency is 3. I'm going to use lowercase f for frequency. Is there any other value whose frequency is 3? Yes. 3. So both 2 and 3 have the greatest frequencies. They both occur 3 times. They both occur the most, so they are both modes. If a data set has 2 modes, it is called bimodal. I don't think I need to explain why. And if you look at the third example, another quantitative data set, you'll notice that I'm kind of addressing the outlier issue again. This is the same data set as the previous one, but instead of 5, I wrote 5,000. So it's an outlier. Will that change anything? Which values still occur the most? Well, it's still 2, and it's still 3. So what that means is mode is not heavily influenced by outliers. In fact, it's usually not influenced at all. I think that's worth writing. Mode is not influenced by outliers. And I know what you might be thinking. Well, what if you sprinkle on 3 more 5,000s and now there's 4 of them and it becomes the mode? Well, if there were 4 5,000s, then it's up for debate whether or not those are significantly larger compared to the entire data set. Again, if you take statistics, you will learn a technique that sets up a boundary that defines who gets to be an outlier. And without going into details, as you start throwing more larger values over there, that boundary moves and those numbers might not actually be considered outliers anymore. Because now you don't have one number that's bigger than everybody else. You've got a bunch of big numbers and a bunch of small numbers. But I digress. If there's one really large or really small value, it's not going to affect the mode because there's only one of them. What about the last one? Red, blue, black, and green. Well, none of those occur the most often. And there are some people that will argue that they are all the mode because each one of them has the greatest frequency of 1. But notice in the definition, if all values have a frequency of 1, then there is no mode. In this case, there is no mode. So mode is simply the value that occurs the most, and it might be more than one value, or it might be none of them, if none of them occur more than once. I I want to leave this video with a thought. It's not really another example, but let's say that I take this last set that only contains red, blue, black, and green, and I give it another red, another blue, another black, and another green. This actually brings up a really interesting theoretical question. If this data set contains 2 reds, 2 blues, 2 blacks, and 2 greens, who's the mode? Well, the answer is either everybody or nobody. Everybody has the greatest frequency of 2. So is everybody the mode? Or is nobody the mode? I mentioned in previous videos about the inconsistency in the subject of statistics, and here's another one. There are some statisticians and some books that will say that everything in here is the mode, because everything has the greatest frequency, and that frequency is greater than 1. But there are also some authors and some books that will say that nobody is the mode, because the idea of being the mode is that you're in there more often than somebody else. Dog is up there more than everybody else. 2 and 3 are in there more than everybody else. Down here, nobody is in here more than anybody else. So in some books, it will actually be another part of the definition that says, not only must the mode have the greatest frequency, it must have a greater frequency than some other value. In other words, you must occur the most, but somebody else must occur less than you. You won't be given a dilemma like this, but I like trying to break things in math, because honestly, math should be well defined so that we don't have these questions like, was the set that I just erased half of, does it have a mode or not? Either everybody is the mode or no one is the mode. Unfortunately, statisticians are just so, well, I'm not gonna berate statisticians. I work with some of them.